Before that, I would just like to remind everyone that I already sent the link for the recording for the short problems. Okay? So, meron na yung main lecture, then short problems. And right now, what we're going to do is some sort of looking at the summary that we have in your module. Okay, so if you're familiar with what I'm saying, it's this part. So this is what the chemical kinetics is all about. Okay, so as we say in chemical kinetics, usually the first question that we ask is whether a reaction takes place or not. Okay, so that type of questions are what we call deals with thermodynamics. So you have already encountered thermodynamics. If I'm not mistaken, thermodynamics is your chapter 5. Okay. Now, if the answer to that question, does the reaction takes place, is yes, so usually, okay, the next question is what we call a kinetic one. The next question would be what? After you're sure that the reaction is taking place, okay, the next question after you would be how fast or slow the given reaction. Okay, so we could say if we're going to summarize what we have discussed so far, thermodynamics answer does a reaction takes place, and then kinetics answer the question how fast. Okay, so you can also have the question here, are diamonds forever? Okay, so when you ask what they call are diamonds forever, do they last forever? Okay, because thermodynamically you could see that your diamond can become what? The ever expensive diamond, it can become what we call the ever cheap pencil lead or the so-called graphite. Okay, and the one that prevents the diamond from the graphite is a kinetic problem. What does it mean? A diamond can become graphite, but the kinetics that you have there is so slow. It will take a million or billions of years before it happens. Okay? So we could say a diamond can last a lifetime. Ganun yung ibig sabihin nun. Now, whenever you look at the kinetics, you look at the chains of your reactant and product. So usually what happened with kinetics, with time? So you start with A, okay? And then after some times, when A starts to produce B, what happened to the concentration of A? So I could put A here. So after some times, okay, A will go down. Now, as A go down, what happened? You produce B. Okay. Now, you can monitor the rate from two perspectives. You can monitor it from the perspective of what? The change in the concentration of B over change in time. Or you can look at it from the perspective of the change of concentration of A over change in time. But you have what we call a negative. Why? Why do we need to put a negative side when we're dealing with reactants?
kasi po nababawasan.
Okay. Since it is decreasing, okay, your initial concentration is higher than your final concentration. So if you don't have that, okay, you're going to have a negative value, but there's no such thing as a negative rate. Okay. So to keep it positive, you multiply it with a negative sign. Okay, the rate has a negative sign in the change in the reactant concentration per unit time because the reactants are consumed in the process while the products are produced. Okay, now you can measure your rate in terms of what we call the average rate. Or in terms of instantaneous rate. Or we could say your initial rate. Now, all of them refers to what? Change in the concentration over change in time. Okay? So when we're talking about the average rate, usually that is the where you uses the concentration at the beginning and end, and over which the reaction rate is changing. So try to imagine, hindi ko alam yung ano kasi nasanay ako dito sa US eh. Ang example na binibigay ko lagi dito, try to imagine a trip from New York to DC. So usually, it's around, if I'm not mistaken, 4 hours. Okay, yun yung average rate. Now, if I'm going to make it into instantaneous rate, during the duration of the trip, going out of New York, the instantaneous rate is very slow kasi traffic. But once you get out, you go to New Jersey, okay, you run faster. So your rate are what we call higher. So at a certain instance, the speed of you running the car is not what we call the same at different places. Okay, so yun yung pinatawag natin instantaneous rate at a specific time. Okay, now yung initial rate naman, we could say this is just the instantaneous rate at time 0. Okay, so when the reaction commences. So yan yung what we call different. But if you're going to look at them, it's just a change in time. Oh no, change in the concentration over the change in time. So we could say this is just the concentration. We could say the final concentration minus the initial concentration over time, final time minus initial time. So you always look at this one. So if you have 2 points here, okay, so let's say you want to compare the 2 points. So if ito yung inano mo, kinompare mo, you can get what we call the average rate. So you're just going to look at that one and then compare it with the initial one. Okay. So usually you're given 2 point in time and the respective rate that they have, and then you're going to get the difference between them. Now, this is, we could say, yung reaction rate. Reaction rate, or interchangeably, you could say the rate of reaction. Pareho lang yan. It's a change in the concentration over change in time. Now, meron din tayong tinatawag na rate expression. Now, yung rate expression, it involves the so-called stoichiometry. So the rate expression just tells you the relative rates, let's say, of the decomposition of reactants with respect to the formation of the product. So kapag nagdi-deal ka ng rate expression, usually you have it like this. So the big letters are the reactants of the products. The small letters are the stoichiometry of both the reactants and the product. So if you're going to look at the rate expression, again, both the reactants will have negative. So the way that you're going to do it is one, negative A, change in time, or change of A over change in time. Okay, and that is equals to 1 over B negative times change in B over change in time. Or you can do it at 1 over C, change in the concentration of C over change in time, and that is equals to 1 over D, change in the concentration of D over change in time. Okay, so,
Sir.
yes?
Bakit nga po pala positive yung sa may side ng C and D?
Because it's a product.
Okay.
The final concentration is much higher than the initial concentration.
Okay.
Okay. Now here you can have what we call the reference point with respect to the speed or the rate of the decomposition, okay, and respect with the formation of the product. So if we're going to make it specifically, let's say N2 plus H2 producing NH3. So usually this is 2, okay, and this is 3. So if we're going to write the expression here, okay, we could say that for every change in the concentration of nitrogen, that is equals to 1/3 in the concentration of hydrogen with time, and that is also 1/2 in the formation of what? NH3 with respect to time. So what does it mean? Okay, whenever there's 1 mole of nitrogen that decomposes, there's only what? The speed that corresponds to 1 mole of nitrogen is just 1/3 of the decomposition of hydrogen, because there's 3 hydrogen that you have there. Okay, and I think in my lecture I gave a specific example on how the calculation is being done there. So yung example na binigay dito, if we're going to look at the module, so you have it this one. Gawin natin specific. N2O2, N2O5, 4NO2 plus oxygen. So if ever at a particular instance, meron kang 4.2 times 10 to the 7 meters per second. So you are asked, okay, so yan yung we could say rate of decomposition. So you are asked what's the rate of appearance. So if you're going to look at the rate here, so this one is negative 1/2. And for every 1/2 that is formed there, decomposed, you have what? 1/4 of the NO2 that is formed. Okay, so if you're going to simplify this one, paano gagawin natin? So you're going to find a number wherein you can simplify them. So if you're going to what? Let's say multiply both sides by 4. Ano yung mangyayari? So for every twice of this, now you might say, where did I get the 2? 4 divided by 2. So you have 1 mole of this. So kapag meron kang this amount, anong ibig sabihin nito? if a particular instance you have 4.2 times 10 to the negative 7, so ang mangyayari yan, the rate of appearance of your NO2 is what? Twice. Okay, that is equals to twice of it. So ang mangyayari, okay, so here as you could see, simplifying them, so for every 4.2 times 10 to the negative 7 of rate of decomposition, yung rate of appearance mo is twice. Okay? So i-multiply mo by 2 kung ano man yung rate nito para maging rate of appearance. Kasi itong value na to, dito to eh. So to get the value of that, okay, you multiply that by 2. So if you look at the rate of the formation of NO2, that is just 2 times the 4.2 times 10 to the negative 7 meters per second. So you might have a question like that. You know how tricky it is, right? So if I'm going to put it doon sa example ko dito, so what it, let's say I have 1 times 10 to the negative 5 dito. So ano yung rate ng decomposition ng H2 at ng NH3? So you have to do it 1 by 1. So here, if you're going to look at this, what will happen? Kapag this with respect to that one, I have to multiply both sides by 3. So ibig sabihin, para maging delta H2 over T2, I have to multiply that by what we call 3. So ito yung rate ng decomposition ng hydrogen when I have this rate of decomposition of nitrogen. And it shows, right? Because this is 3 times compared to the N2. Does it make sense? Just try, okay? So we have this, right? Now, if I have, let's say a rate here, like this one. So I want to find the corresponding rate in terms of H2 and in terms of NH3. So I look at the relationship that they have. So this is what? Negative 1. No, that's just negative delta N2 over delta T. And that is equals to negative 1 over 3. So ano yung given? Ang given ay ito. So yung rate na ano dito, if you replace it, that's the value. So what do you want? You want it to express with this. So how do you express it in this one? Paano mo tatanggalin yung 1 over 3? Or yung negative 1 over 3? You multiply both sides by 3. So ibig sabihin, kung ano man yung value nito, i-multiply mo siya by 3 so that you can get the rate of H2 with respect to the rate of N2. So ganun din dito. So if you have N2 over delta T, okay, and you want it, so this is what equals to 1/2. Where did I get the relationship? Doon sa stoichiometric ratio. So how will I express this thing in terms of this? Paano mo tatanggalin yung 1/2? You multiply both sides by what? 2.
By 2.
Now, since the rate of this is 1.0 times 10 to the negative 5, So if you want to express that with respect to this one, you just multiply that by 2. Klaro ba? So if you're going to look at your module, I'm just using the module material. This is where you can find it. I'm just trying to make it what we call the same as those in the recorded lecture. And then you are asked here some of the factors that affect the rate of reaction. So ano yung nagpapabilis at nagpapabagal sa rate of reaction? So maybe we have the nature of reactants, the concentration of the reactant, and then you have what? The temperature, and then the presence of the catalyst. And I think I have give example on this doon sa tinatawag natin recorded lecture ko. Okay, so if you're going to look at this factor, so if you're going to look at our module, meron siyang tinatawag nating resources na available. So if you click the link here, and there's a simulation that you can see there. Maybe I can look, I can show that to you. So you can see here the reaction rates. If you run the reaction, kita nyo ba? And you can what we call change the variables there. So if you want to control, we say there's a catalyst, there's a concentration, the surface area, the temperature. So what we have is the control. So what if we have temperature? Okay. So let's see if we increase the temperature. Let's look at the reaction. So what can you say about the reaction? Did it go up or down when you increase the temperature? Okay, tumaas.
Tumaas.
Yo, that's the what we call dotted line. So if I start over, if I increase the temperature, okay, it's higher than the one you have in the control. Okay. Now, if I did it the other way around, if I decrease the temperature, look what happened.
Decline.
Now, if I'm going to what we call put it in terms of the surface area, okay? So if I increase it, it also go out. So what is a possible surface area? So usually, the smaller the size of the materials involved, the higher is the surface area. Okay, if I decrease it, kita nyo, mababa din yung kanyang reaction rate. Okay? And then we can also look at this what we call concentration. So pag mas mataas yung concentration, mataas yung reaction rate. Now, if we lower the concentration, okay, it is much lower. Now, the last but not the least is what we call the catalyst. So the catalyst is any substance that you add to make the reaction faster. So in the presence of the catalyst, you find an alternative pathway, okay, that makes the reaction faster. So makikita nyo yan doon sa module nyo. Okay, and then there's also a material that tells you about the factors that affect your stuff. So the first thing ay tinatawag nating nature of the reacting species. Okay, so it depends on the identity of the species that you have. So merong materials like sodium, when you put it in water, the reaction is so fast. Unlike other materials like calcium, which is what we call slowly. Okay? And then yung tinatawag nating subdivision of the reactant. So if you're going to look at this, so this is something to do with what we call the different surface. So you can look at the reaction here. So this is a professor whose specialty is in the elements in the periodic table. And this is the advisor of my colleague at Pace University. So he's from England. Okay. Now, with regards to the temperature of the reactant, so temperature usually measure the speed of your material. So the higher the concentration, the higher the temperature, the faster the movement of what we call the material. So whenever you have a reaction, you follow the so-called collision theory. So they said for a reaction to occur, molecules should collide with one another. Okay, so try to imagine cars in a parking area. So if we look about like at the temperature, we look at the speed of the car. So what's the likely you're going to hit another car? Okay, when you're running at a faster speed compared to a slower speed. So ganun yung effect ng temperature. Now with respect to the concentration, try to imagine a parking area na puno-puno ng kotse. The likely that you will collide with it is higher compared doon sa halos lahat empty space because of the concentration. So those are, we could say, the factors that can affect the so-called reaction rate. Now, the next thing that we have here is the so-called rate laws. So, ang dami ng term natin na reaction rate or rate of reaction. Meron tayong rate expression. So, ano naman ngayon rate law? So, paano nagkakaiba yung rate law compared dito? Kasi ito, pareho lang na parang ganito eh. Right? Now, one way that the rate law is different, it only involves the reactant. And another way to look at this, so if you have a rate law, you have a rate of reaction, and then you have a K. You have reactants that is raised to a coefficient. So ito yung rate law. Meron kang rate constant at meron kang number na to. And this X and Y, it doesn't have to do with the coefficient. You have to experimentally determine them. Yan yung tinatawag nating reaction order. Okay? So if we have what we call the rate law, the way that we have this what we call rate law is we're going to determine the rate law from experiment. So ano ibig sabihin yan from experiment? So usually there's 3 set of experiment. If you have 2 reactants, so let's say A and B, and what you have there is the initial rate. So what are you going to do? So let's say you have this. So how are you going to express the concentration here? So I can put here, this is what? 10. Okay, and then this is so how could I determine the X or the order of the A here? Okay, so what I do, I'm going to use this and see what's the initial rate while B is the same. So if I'm going to do that, that's 0.20 over 0.1 equals to 10, oh no, 20 over 10. So look,
Sir, hindi po kita sa screen.
ay, sorry. Sorry.
Pasensya na po.
Oh, hindi pala ito. Libre text pa pala tayo. So usually, if we have what we call the rate law, ito yung pagkakaiba ng rate law kaysa doon sa reaction rate or rate of expression. Meron kang rate constant at meron kang raised to the power, okay, that you determine experimentally. So how do we get X and Y? So you have to do an experiment wherein you vary the concentration of the reactants. So to get the order of the X, you look at the one where you change the concentration of A while B is the same. So the same thing, if you're going to get the order of the B, you look at the concentration where the B concentration changes while A remains the same. And look at the changes in the initial order. So if we have, let's say, this one, so we use this because B is constant. So we look at the order, this is what, 2, and this is 2. So what's the value of X to make 2 raised to X equals to 2? So usually it's just 1, right? Now, how about the B? So this is the X. So how about the B, the Y in the B? So you can use this one and this one. So you can have what? 0.20 over 0.1 equals to 40 over 20. So that is also equals to what? 2. So 2 raised to the Y equals to 2. That is equals to 1, right? Now, what if we make this 80? Ano mangyayari dito? So this is 80. So this now becomes 80 divided by 20. So anong value ng Y para 2 raised to the Y will give you 4?
Ito po.
So here, if we're going to have it here, if we're going to write the rate law, we don't write the 1. It's understood to be 1. And this one is squared. Now, what if instead of what we call this one, I get it like that? So paano yung order nito kapag instead of 20, 10 siya? So it is what? 0.20 over 0.1 equals to 10 over 10. So this is 2 and this is what? 1. So what is raised to the 2? Or 2 raised to the X will give you 1. 0. And if that happen, ganito yung rate law mo. Clear? Hindi mo na isasama yung A kasi 0 order siya eh. So, ibig sabihin, baguhin mo man yung concentration niya, hindi mababago yung kanyang initial rate. Now, this is what we call the basic reaction, the basic rate law. So you have to determine them experimentally. Wala siya doon sa coefficient na sinasabi natin. Okay? And the last part that we have here ay yung tinatawag na integrated rate law. So in the integrated rate law, you try to look at the concentration when they change in time. So meron yang mga order. Meron kang 0 order, meron kang first order. So it's a little bit long, and I think I have it in my lecture. And meron kang tinatawag na second order. So if you're going to look at the first order, we start with the zero order. So in the zero order, usually what do you have? Okay, the rate is just equals to the K. K is what? Ano yung K natin dito? K is your rate constant. Okay? So if you're going to plot yung what we call zero order, ito yung plot niya. Kita niyo yan? A equals to initial A minus KT. So what does it mean if you have it on the line? So this is the time. This is the A. So in other books like me, I put it 80. So that is the concentration we change in time. So if you're going to look at this, meron kang initial concentration. So if you're going to look at this, it's just plot in the so-called y equals to mx plus d. So ano yung x? Siya yung time. Now, based on this, what we call slope of the line, paano yung graph ng zero order? Is it A going up, B going down, C like this, D like that? So anong sagot nyo? Type nyo sa ano, sa chat. Oh, this one. Hindi na naman pala ako nag-share. So anong itsura ng graph kapag meron kang ganito? Ito kasi yung zero order eh. So is it A, B, C, or D? So the answer is B. What gives you that it's going down? This one, the slope is a negative K. So that's the first order. No, the zero order. Now in the first order, it is Ln. Usually, ganito yung ano niya sa ibang book. Minus KT. So if you want it to be in y equals to mx plus b, so you have to separate these two. So it's usually like this, equals to Ln initial A minus KT. So again, ano yung slope? If we follow the ABCD here. I mean, ano yung itsura niya? So ito yung first zero order, so ito yung first order, so that's time. So this is the Ln of A. So kita nyo sa y-axis, Ln of A siya. Sa zero order, A of T lang siya. So ano itsura ng graph? So it is also B. Your plot would be like this.
B pa rin.
Because you have a negative K. K is what? K represent your slope. Okay. Now, the last one that you have there, you have what we call the second order. Now, the second order will be represented by what? 1 over A minus 1 over initial A equals to KT. So, if you're going to what we call put that in y equals to mx plus b, it is just KT plus 1 over A. So, ano yung itsura nito? 1 over 80 versus T. So ano yan? A going up, B going down, C straight line, D straight line. So anong tama dyan? If you have this what we call thing. Or they're going to give you a plot. T versus ln of A, or T versus A, or T versus what we call 1 over A T. So sa tanong sa inyo, alin dito ang zero order, first order, second order. So this is the zero order, the first order, and the second order. So here you now have A going up because you have a positive K. Now I gave the specific problem solving doon sa short end, but I think I have an example also doon sa long lecture. Now, in other thing that they have, gaya dito sa example sa module, you are asked to get what? The order of the reaction. You're given like that one. How are you going to do that? So kapag meron kang ano dito, you are guide question. So you are asked how are you going to do that? So you need to graph them. So if I have this value here, okay, I'm going to graph them so that I will be able to get the thing. So paano ko siya i-graph? So i-graph ko siya time versus A, concentration with time. So I'm going to use this value that you have here. And then in another one, I'm going to graph them time, and then I'm going to convert this into ln of NO2. Yung kukunin ko yung ln ng value na to. Tapos i-graph ko siya. Tapos doon sa second order, yung time versus what? 1 over the given value. And then what do I do? Sa plot na ginawa ko, titingnan ko yung R squared. Okay? Yung R squared that is closest to 1 will tell me ano yung reaction order. Maybe we can do that. Let's see. So, buksan ko lang yung Excel. So you will see. So as you could see, I open Excel. So what I'm going to do is I'm going to copy. Usually lab experiment to 0, 50. Kita niyo Excel? Class?
Yes po, kita po sir.
Okay. So I have a point 0, 1. So I can plot that. So this is a 0. And then what will I do? I'm going to get the R squared. So usually I use the trend line. I'm going to get the R squared. So look at the R squared. Do you see the R squared? Kita nyo ba yung Excel? Now what will I do if I want to make this into a first? So I'm going to convert this to ln given yung value na yan. Then I got that one. And then I just copy this one. Nope, not that one. Ang gagawin ko lang, imumove ko lang to dito. Now look at the R squared. Kita yung R squared? It's much better than that, right? 0.984824 compared to 0.9274. And then I'm still going to do that. So this one divided by that one. And then I'm just going to get it. So now this is the second. Then I'm just going to copy this. And this time, what will I do? I'm going to move it like that. So which is the best? And siya, first, zero first or second order. Have you seen the R squared for the second order? It is what? 1. Okay, so it is a second order. Because that's the one that is really closest, if not 1. But I don't think, ewan ko kung ganun sila mag-aano. Tawag dito yung mga question na tatanungin sa exam. Usually we do it on the laboratory portion. Now the last part that we have here ay yung tinatawag nating collision theory. So sabi ko nga sa inyo, for a reaction to occur, they should be colliding with one another first. No collision, no reaction. At lumalabas dito yung tinatawag nating Arrhenius equation. Now, for a collision to be what we call successful, it should be effective. So meron siyang orientation, proper orientation. Like for instance, when oxygen react with CO, if the orientation, kita niyo yung yung reaction. So if the oxygen is the one hitting the oxygen in the CO hits the oxygen molecule, wala kang reaction. But if it's the carbon in CO that hits the molecular oxygen, doon ka mag-perform ng CO2. Yun yung tinatawag nating effective collision. Meron tayong tinatawag na proper orientation. Okay? Now, in this what we call the reaction, meron tayong tinatawag na thermodynamics. So for instance here, yung tinatawag na activation energy. So for a reaction to be successful, you have to overcome a hill na tinatawag nating activation energy. Okay? So in a forward reaction, the activation energy is this height. But in the reverse, ano yung activation energy natin? If we reverse the reaction. So right now, let's say we have it like this, right? Now, if you reverse it, ano yung activation energy? So here, the activation energy is this one. But here, what is the activation energy? The activation energy is this whole thing. Now, the presence of a catalyst will give you an alternative pathway wherein the activation energy is much lower. Kaya mas faster siya. Okay? So involved dito sa collision ay yung tinatawag nating Arrhenius equation. So ano ito? Sabi nila, kapag mataas yung temperature, mataas din yung rate constant. So there is what we call a formula that you need to use to help example like this. And I think that's one of the problem, the video with the short problem that I included. Like this. So ito yung ibig sabihin nun. So this is the formula that you have there. So this is all the chemical kinetics is all about. Now, how deep it will be, well, it depends. Pero ang assurance ko lang sa inyo, yung quiz na ibibigay ko sa inyo, katulad din doon sa exam. Sa tanong, may tanong. May ano na ako. Can you just show up yourself in that class? Ako. Sa tanong, yung quiz, I think after New Year na. So may papakita lang ako sa inyo. Matthew, come here. I want you to submit that kasi igagawin kong available yung answer doon sa problem set maybe during the break. Pero you're not really required to do something. As I've told you, I want you to enjoy your holiday. After New Year na lang problemahin yung tinatawag nating last exam nyo. As of now, hindi pa natin alam. Tapos yung result ninyo, ayaw pa rin nilang i-release kasi may mga correction ata. Kasi karamihan ng score, nagreklamo ko, bakit sabi ko may 0.67, may 0.33. So once na hindi pa nila kiniklear, hindi pa kami pwedeng maglabas ng score ninyo. Yun yung problem na nakita namin. So tanong, ready na kayo sa last meeting natin? Tayo